supplies Q equal to MLF. Who will supply this heat? The rod only. So therefore, what is Q is equal to? H equal to V know Q by T. In turn, what is H equal to? Ka Ts minus 0 by L. Small l, I'll write it, you'll get confused. Equal to, in place of Q, what you can write? MLF by T. So what is the time taken? MLF small l by Ka Ts. So the time taken for the ice to melt depends on what? If amount of ice is more, yes, definitely take more time. If the length of the rod will increase, then the ice will take more time for it to melt. Getting this one? Let me take the iron rod. K will be more. Let me take some material where K is less, then it'll take more time. If I increase area of cross section, yes, what happens? More it will flow, the ice will melt very soon. Okay, these are the things which are going to help us a lot in designing of any of the system. Okay, just don't end up mathematically. Try to analyze this time taken for the ice to melt. Depends on what all. For all ice to melt, time taken for all ice to melt. I think we can really start analyzing. No, this will be so as the length of the rod increases, it will take less time. It will take more time. You say that one. If temperature of source is more, as more it will flow, then it take less time. So in designing of so many structures, no, all these basic ideas are being implemented. So earlier I brought body. Sir, why here temperature of ice will not change? You know, we all know that for ice to melt, when a body changes its state, what will happen to the temperature? Will not change, no? No, common sense. Next, shall we take a situation where both the ends of the rod are connected to a bodies? M1 S1, temperature T1, temperature T2. This is a thermal conducting rod. This is insulated. Let L be the length of the rod. Thermal conductivity K, area of cross section. I want at T equals 0, the temperatures are T1 and T2. T1 greater than T2. At initially, what is the temperature difference? T1 minus T2. With the time, what will be the temperature difference? Okay, let me add up the question. Two thermal, two bodies. Let me add sentence like this. Sir. A thermal conducting rod is connected across two bodies that are at different temperatures as shown. At T equals 0, the temperature difference is T1 minus T2. Find the temperature difference between the bodies at any time T. No, T1 greater than T2. So which will this is a hot body, or this you can say warm body. I'll connect a rod. So the heat will flow from here. What happened to temperature of this? Decreases. Temperature of this will increase. Instead of this body, no, you can take a gas also. Here, diatomic gas, monatomic gas, this is at higher temperature T1, low temperature T2. Then the gas will exchange it through a rod. I want the temperature difference between the gases at any time T. Okay, get into the problem now. Previous problem, what happened? One end was temperature of one end of the rod was constant, the other end was varying. Now here both ends, the temperature is varying. So how to analyze such numericals here? Okay, let T be the temperature difference at any time T. I'll proceed like this. Let T be the let T be the temperature difference at any time T. Then what is T? We can write it as T1 minus T2. With the time, there's a odd body. Okay, I think let me write at least you'll understand. There's a warm body. Okay, now from where to where the heat will flow? From the odd to the warm body. So tell me temperature T1, will it increase or decrease? Will decrease, no? T2, temperature of this will increase because it gains heat. So what actually is? Odd body loses heat and warm body gains heat. Let's get into the thing now. It's very simple. This is 100, this is 40. With the time, what will happen? The initial temperature difference, how much? 100 minus 40. Please do analyze. 60. After some time, this will become 80 and this will become, say, like a 55. How much it is? 35. So look at the temperature difference. Earlier it was 60. At any time, it is 35. So with the time, what will happen to temperature difference? Will decrease. Temperature of hot body will decrease. Temperature of warm body will increase. This is the thing which a student has to analyze. Students will not think. He thinks that okay, by mathematics he can do anything. You just go do integration, you'll end up with the wrong answer. The observation has to be made. Okay, the integration will end up like this. Dt is equal to, I'll put negative sign. At least you should justify why these negative signs. Temperature difference will decrease. Temperature of hot body will decrease. Temperature of warm body will increase. So therefore it will be. So therefore this will become dt1 plus dt2. Okay, now what all heat gained, what all what all heat lost by this? We'll transfer that. I'll write some very important thing. This hot body will lose heat, no? Say some amount of dq. And what happened to that? That will flow across the rod, and that will be gained by whom? By the warm body. So therefore, what all heat transferred by the rod, what it is equal to? Heat lost by the hot body or heat gained by the warm body. Okay, I'll write it. dq is equal to m1 s1 dt1. What you should write comment for this? Heat transferred by the rod, heat lost by the hot body, heat gained by the warm body. warm, or if you want to write cold body, anything like if you want, I'll write it cold, so that it'll be easy for you. Hot, cold, so it will flash for you a lot. Heat gained by cold body. Okay, I agree this. So there's a condition. Okay, now let me replace dt is equal to, let me enter into the solving part. Okay, there's enough of physics. Rest all everything, let me replace dt1, dt2, I'll replace it. So this will be m1 s1 dt1 by m2 s2. I'm substituting this equation 1, 2. M2 s2. So what is the expression for dt1? dt1 equal to m2 s2 dt by, if you want, you can replace that with a heat capacity also, because mass into specific heat will become heat capacity. Okay, this is what dt I'll get. So now let me get into the calculation part. H is equal to Ka T by L. What is T? Temperature difference. Already we wrote it. What is H? H should be equal to dq by dt. What is dq? Heat lost by the odd body minus m1 s1 d1 by dt. dq, heat lost. That should be equal to Ka. What is dt1? Already we have solved it. No? dt1, I'll substitute this, minus m1 s1 m2 s2 by m1 s1 plus m2 s2 dt by dt. This should be equal to Kat by L. Let me write all this as some alpha. Dt by t equal to alpha dt. What is alpha? Ka, then everything is alpha. Okay, let me integrate now. So this will be, what is t? Already I defined it. Let's get into this one. What should be the limit? Initial temperature difference. How much it is? T1 minus T2. Final temperature difference is T. So this will become log of T. Sending on that side, e to power of minus alpha T. So this is the expression. What is the temperature? It will decrease exponentially. I think I should bring a graph so that you'll understand what actually it is. This is a time in seconds. There's a temperature difference. So initial temperature difference is how much? You are plotting temperature difference. So what will happen is, at t equals 0, temperature difference T1 minus T2. With the time, what will happen? It will decrease exponentially. It's telling. Put t equal to 0, put t equal to infinity, will become 0. Finally, what happens? The temperature difference. Both the bodies will have same temperature. Means when you connect a odd body with a cold body using a rod, how the temperature difference will vary with the time. It will not be linear, will not be sudden. Suddenly it will, temperature difference will become zero. No, exponentially decreases. That's what the curve you mean to say here. Are you able to understand now? Okay, now I'll ask you one of the best question. Is it not a steady state? Because as a teacher, what is the state of rod? At steady state, tell me what will happen. Anybody wants to add comment? At
Only transfer of heat, sir.
no absorption of heat. At steady state, what should happen to thermal power? Constant or can vary? Huh. At steady state, thermal power or heat current should be constant or can vary.
Can vary.
Can vary. Again, we should not conclude that at steady state, the thermal power should be constant. It can vary. Look at this H now. So I think now we have expression for H you substitute here. What is the T? You write it. So let me write, because that is something very, very important, because these things will trouble you a lot in more than one options. So the expression for heat current is equal to KAL T1 minus T2 e to power of minus alpha T. Look at the thermal power. Initially, how much it will flow? Ka T1 minus T2 by L. With the time, what will happen to thermal power flowing through the rod will decrease. And it's just steady state only, again still. So steady state means, doesn't mean that H must be constant. So H can be varying. Only thing is, no part of the rod should absorb it. All the parts of the rod should be involved only in the transfer of it. That is the meaning of steady state. So at steady state, H can vary with the time. H can be constant. I think I should write a comment here. Note, at steady state, thermal power, I'll write it. Thermal power flowing across rod may be constant or may vary with the time. So steady state doesn't mean that H must be constant. Okay, agreed now? That's what this particular question is, what is reflecting the idea. Because the moment steady state means, what students will think is, most of us will think in the beginning like, okay, H will be constant. We took numericals of that kind where H was constant. Here H is varying. So at t equals 0 or at any time t, no part of the rod will be involved in absorption of it, only in the transfer of it. That's the meaning of steady state or thermally lagged. Even if you say like, okay, the rod is thermally lagged, okay, the same thing. You mean to say that much only, the condition.
Sir,
Ah.
so could you scroll up once, sir? Sir, in equation 2, dq is equal to minus m1 s1 dt1 s1.
Magnitude. Here is what I should write in the equation. How much heat will flow through the rod means what all heat lost by this body is what that heat flown through the rod. Heat flown through the rod is not negative, no?
Okay, sir. Okay, understood.
Yeah, that is what. That's why I wrote separately this. This is very important. Here, if you write minus, all things will get disturbed. Okay, no, see, no, sir, I'll put minus sign. Okay, put minus sign and work out. Common sense what says that temperature difference will increase or decrease with the time. Will decrease with the time. That's what the cross check is what I'm doing here. I didn't say nothing wrong in assumptions, but it should be verified.
Yes, okay.
Okay. Okay, these are the slowly some series parallel, different shaped, then both ends of the rod. Uh, Numericals is what you'll be coming across, and the method is what you can apply it. Let me introduce to one more idea. It's a very good lengthy chapter. Only thing is, students, somehow if you can understand the methodology, and whenever series parallel comes, take help of Ohm's law, because you know most of the basic in high school, you studied about the Ohm's law, some Kirchhoff's law, no? So those ideas, what happen, you should take help of here.